Today, we're diving into a really fascinating paper that asks a huge, and I mean huge, question about AI. What has a foundation model actually found? We're about to jump into a high-tech detective story. And here's the central mystery, the big question that sounds like it's straight out of science fiction. Can an AI learn the fundamental secrets of the universe just by watching? Could it just look at a stream of data and figure out the deep laws that govern everything?
Okay, let's get into it. It all starts with the incredible promise of these big foundation models. The hope, the dream really, is that they don't just do tasks, but that they actually understand the world on some level.
The core idea here is actually pretty simple, but it's also incredibly powerful. If you can get a model to be really, really good at predicting the next thing in a line, the next word in a sentence, the next frame in a video, or the next position of a planet, well, it might be forced to learn the underlying rules of that system. It's kind of the same path scientists have been on for centuries.
To really put this idea to the test, the researchers used this absolutely brilliant historical analogy, the difference between two giants of science, Kepler and Newton.
And this comparison really breaks down a critical difference. So on one side, you have Kepler. You can think of him as the ultimate predictor. He figured out these geometric patterns that could tell you what the planets would do with unbelievable accuracy. But he couldn't tell you why. That's where Newton, the understander, came along. He discovered the universal law of gravity, which explained the fundamental force behind all of it. And that brings us right to the million-dollar question for our time. When we look at these incredibly powerful AI models, are we looking at modern-day Keplers, just amazing prediction machines? Or have they actually made that leap to becoming Newtons, to truly understanding the principles underneath?
So to find out, the researchers couldn't just, ask the AI. They had to be clever. They had to put it to the test with a really slick experiment. Let's see how they did it. They designed a test for something called inductive bias. Now, I know that sounds super technical, but you can just think of it as a model's gut instinct. It's the set of built-in assumptions it falls back on to make sense of the world, especially when you give it just a little bit of information and ask it to figure out the rest. So here was the game plan. Step 1. They trained a foundation model to become an expert at predicting planetary orbits, basically to be a digital Kepler. Then, step 2, they gave it a new but related physics problem, but this time with hardly any data to learn from. Step 3, and this is the key, was to see what gut instincts, what inductive biases it used to solve that new problem. And finally, they'd compare those instincts to the actual real laws of physics. And the results? Well, this is where it gets really, really surprising. The world inside the AI's mind, it turned out, was a pretty nonsensical universe. Now, let's be super clear. The model was a fantastic predictor. Just like Kepler, it could plot orbital paths almost perfectly. It absolutely nailed the what. But the real question, the big one, was still on the table. Could it think like Newton and actually understand the why? And the answer was a huge, resounding no. I mean, just look at this. On the left, you see the true force law of gravity. It's simple, it's elegant, it's orderly. But on the right, that's what the AI came up with. It's a chaotic, nonsensical mess. For all its amazing predictive skill, the model completely, spectacularly failed to grasp the simple, fundamental rule. And honestly, it gets even weirder. When the researchers translated the model's internal logic into actual equations, they found it wasn't just wrong. It was inconsistently wrong. I mean, look at this table. Instead of Newton's simple, elegant law that works everywhere, the AI invented these bizarre, ridiculously complex, and, get this, different laws for different situations. It wasn't learning a universal rule at all.
So, what on earth is going on here? This gets right to the heart of how these models might think. And the crucial takeaway is this. Prediction is not the same as understanding. Not even close.
So instead of building one single, universal, robust model of physics, the AI was just taking shortcuts. It was developing these highly specific little tricks or heuristics that worked perfectly for the one prediction task it was given, but they didn't generalize at all.
they weren't real knowledge. It seems like the AI learns a much simpler, almost coarsened or fuzzy version of reality. It just focuses on whatever it needs for the immediate task. So in the physics test, that meant making up separate bonkers rules for each galaxy. But this isn't just about physics. They found the exact same thing happening when they taught an AI to play the game of Othello.
Okay, this part is just wild. Researchers trained a model on tons of Othello games, and it got incredible at predicting the next legal move. But, and this is the kicker, when they probed its internal map of the board, they found that the model's mental picture was often completely wrong. You can see the errors marked right here. Yet, it could still predict the correct moves perfectly. It had found a shortcut that didn't even require knowing the true state of the game. In other words, it wasn't learning the fundamental rule, which is, what is the state of the entire board? No, it was learning a much simpler, dumber shortcut. What moves are legal for me right now? It was getting the right answer, but for a totally different and, frankly, wrong reason.
And this has absolutely huge implications. It strongly suggests that even our most powerful, most advanced foundation models might not be building the deep, comprehensive, robust world models that we kind of assume they are. They might just be expert predictors, getting by on a whole collection of clever, but ultimately fragile shortcuts.
Which brings us to this really powerful final thought from the researchers themselves. These models excel at prediction, but they may be relying on clever heuristics, not a genuine understanding of the world. So this leaves us with a critical question to chew on as we build even more capable AI. How do we make sure our models aren't just brilliant predictors, but that they actually know what they're talking about?